Welcome to today's short. This is for my finite math students where we're studying inductive patterns. Today we talked about the strength of a pattern, and we talked about counterexamples, and we talked about how if you increase the amount of data, the stronger the pattern. This video will be a voiceover showing the main points of the lesson. Please remember to like and subscribe and leave a comment. Strength of induction. Induction does not always ensure that the predicted pattern will continue according to the conjecture. Consider the following pattern 1, 2, 4. Due to the fact that the empirical data is limited, there may be many possible continuations to this given pattern. As more data is added, the pattern becomes clearer or stronger and more usable. Let's take a look at the first example. If we use the differential method on the first example, the first three terms are 1, 2, and 4. And if we were to use induction, we would see that by finding the difference or the differential, 2 take away 1 is 1, 4 take away 2 is 2, and then 7 take away 4 is 3, and 11 take away 7 is 4. So we see that the change is increasing by 1, so by inductive logic, we would say that the 11 would increase by 1 more than 4, so 11 and 5 is 16, leading me to my next term. Consider the center pattern. The first three numbers are still the same, except for this time, when we do the differential method, we find out there's a difference of 1, 2, then a difference of 4, and then a difference of 8. This time, we can see the change is doubling. So 1 times 2, 2 times 2, 4 times 2, times 2. And then if we continue this with induction, that means it's going to be 8 times 2, or 16. We add 16 and 16, and we get 32. Consider the last pattern, 1, 2, 4, 2, 1, 2. What this pattern is a cyclic pattern. It's 1, 2, 4, 2, and then the pattern continues to repeat. So that would be 1, 2, 4, 2, and then it would just repeat from then on. Now let's consider the original pattern, 1, 2, 4. If this pattern was given, the strength of induction is weak, but if we did the differential, we would say, okay, a difference of 1 and a difference of 2. So the student would say, well, this should be a difference of 3, and that would give me 7, much like the first pattern on the left. But the 7 doesn't work for the middle pattern, nor does it work for the pattern on the right. So 8 would be what we call a counterexample, or the 2 in this case would be a counterexample. When we have limited information, counterexamples are easier to find. Now, just because we cannot find a counterexample in a pattern doesn't mean that it does not exist. It may still exist. It may become very difficult to find. Remember, the more information or data that is in the pattern, the stronger the induction. Also, just because it's a strong pattern doesn't mean that the next term is guaranteed. A counterexample may exist. Even though there's a lot of data and a counterexample has not been found, that doesn't guarantee that a counterexample does not exist.